Alrighty, welcome to day number 3. We are going to be talking about complex fractions. So pretty much a complex fraction is a fancy division problem. So you can do it two ways. Step number 1 is you could simplify your numerator slash denominator. You can flip the second fraction, and then multiply, keep, change, flip, and then cancel. Or what you can do is multiply everything by your LCD. Alrighty, so we're going to get into an example. And so now let's take a look at number 1. Uh-oh. It disappeared. Here it is. Okay, so number 1. I'm going to do it the first method. This is one fraction divided by another fraction. So I got 3x over 4 divided by 9x over 10. So what we're going to do is we're going to keep my first fraction. We're going to change to multiplication, and then we're going to flip my second fraction. So now what we're going to do is we can cancel. So I can take out a 2 from the 4 and the 10. And I can take out a 3 from each one. And I can also take out an x. So now we cancel whatever we can. And now we multiply. 1 times 5 is 5. And then 2 times 3 is 6. And that is your final answer. Now, from now on, I am going to show you how to do it using the second method for all these problems. So the very first thing that you're going to do is you're going to factor whatever you can. So now what you're going to do is find out your least common denominator between all your fractions. So I have x minus 4, that's what's in common. And then I'm going to bring along my x plus 4. So now that's what you're going to multiply to the top and to the bottom. Alrighty, so now what you're going to do is it's really essentially over 1. So now you're going to cancel whatever you can. X minus 4 is on the bottom, that's on the top, so that goes away. And I'm left with 3 times x plus 4. And now I'm going to take a look at the next one. Actually, both of them disappear, so you're only left with 2. And that is your final answer. Do not distribute, just leave it exactly like that. Alright, number 3. What I'm going to do is find out my LCD between every single one. So between the 9 and the 3, it's going to be a 9. And now whenever you want to do it with variables, you always take the highest one. So that is my LCD between every single thing. And now you multiply to the top and also to the bottom. So now we can simplify whatever we can by canceling. Alright, so the 9 and the 9. And then I have n here, and this becomes n to the 4th. So I have n to the 4th times n minus 15. And now I have a 3 goes into 9 3 times, and then n to the 5th goes away. And so then I'm left with 3 times 15 minus n. So now, if you remember from the very first day, if you notice, see how I have n minus 15 and 15 minus n? These two things will be negative 1, because you can factor out a negative 1 on the bottom, and it's going to give you the same thing on top. It cancels, so that's how you're left with negative 1. So your final answer is negative n to the 4th all over 3. Number 4. So we're going to find my LCD between all my fractions. So I have 3 fractions. It's okay if it's only in common between 2 of them. So it gives me x plus 2. And that's the only thing that I have in my denominator. So since you have 3 fractions, you're going to multiply your LCD to every single fraction because you can cancel stuff out. This is the nice part of doing this method, is because it gets rid of the denominator. It makes it a lot simpler. So my x plus 2 goes away, so I'm left with 2 over x plus 2. X plus 2 cancels out, so I have a 1. I can't cancel anything else out because these two things are on top. So that's why you just have to multiply them together. So now what we have to do is we're going to distribute. And now we got to make sure we write it in standard form. Alright, so I'm going to tell you guys, you do need to actually factor down stuff some more. So you got to look at the denominator and say, what numbers can I multiply to 1 that will add up to 2? So it's going to be x plus 1, x plus 1. And that is your final answer. You might say to yourself, why do I need to factor it down? The reason why you want to factor it down more is because of the fact that sometimes you could be able to simplify things out. So let's just say that you got it to be, hypothetically, this is a different problem. Let's say when you did it all said and done, you're left with x plus 1 on top, and then you had x plus 1, x plus 1. What do you notice? You could cancel out the x plus 1. So that's the reason why, is because if you don't have it factored, you can't see what you can get rid of and what you can cancel out. So that's why it's very important to always say, can I take it down even more? Now, let's take a look at the back. So the very first thing that you're going to do is say to yourself, can I factor anything? And you cannot. So what you're going to do is find your LCD. What do they have in common? It's okay if it's only in common in one of them. I mean, 2 of them. And then you bring along the rest. Since I have 3 fractions, that's the number of times that you're going to multiply my LCD. Alrighty, so now what we're going to do is we can cancel stuff out. We can do one of my favorite things. I love canceling. X plus 1 and x plus 1 goes away, so I'm left with 3 times x minus 2. And now I can cancel out x minus 2, and I'm left with 5 times x plus 1. And on the denominator, I can cancel out x plus 1, and I'm left with 5 times x minus 2. So I am only going to simplify my top. I'm going to keep my bottom just like this. So I'm going to simplify my top by distributing 3x minus 6 plus 5x plus 5 all over my denominator. And now I get to combine like terms. Alright, so we want to keep it unfactored on the denominator, because if you don't, you won't be able to recognize if you are able to simplify down even more. Can you cancel stuff out? So that's why this is your final answer. Alright, number 6. The very first thing that I'm going to do is factor everything. So I can say, how do I factor that? Step number 1, find your greatest common factor. And then on the bottom here, I can find my greatest common factor. Alright, so if you notice, you can actually simplify this fraction here, and you can simplify this fraction here. Okay? You can do that. I am not. It's okay. We can do it either way. Okay? I'm just going to take a look at my LCD. And I'm going to check off what they all have in common, and then figure out my numbers. So between my 4 and my 2, it's going to be a 4. So I am going to multiply every single thing by my LCD. Alrighty. So now once you do that, you get to cancel. Yay! I can cancel out both of them, and I'm just left with 2. And x plus 3 goes away because one's on top and one's on the bottom. And the 2 goes into itself once, and this becomes a 2. And what I do next is just multiply. 4 times 2 is 8. Plus, that cancels out, so I'm left with 4 times 1, which is 4. And I get 2 over 12. And so now what I got to do is I'm going to simplify my fraction as 1 over 6. So that is my final answer. Alright, let's take a look at number 7. So the very first thing that I'm going to do is I am going to factor whatever I can. This is x plus 2, x minus 2. So now what I have to do is find out what my LCD is. It is okay if it's only in common in 2 of them, or 3 of them, or it could be in common in all. So they check off what they have in common. It looks like they have x minus 2 in common between 3 of them. It's okay. It was not in common in all. And now I can take out x plus 2. That is what is also in common. So that is my whole LCD. So now what I'm going to do is I'm going to multiply every single thing by my LCD. All 4 of my fractions. Because I get to cancel. I get to simplify. I can make it not look as complicated, which is really nice. That's why I like this process. Because you are able to cancel stuff out, which is awesome. And it doesn't look as scary. So now I take a look at my first fraction. X minus 2 cancels out. So I'm left with 3 times x plus 2. Now, if you notice in my second one, both of them cancel out, so I'm just left with 6. And now, if you take a look at the next fraction, my x plus 2 cancels out, and I'm left with 3 times x minus 2. And now my x minus 2's cancel out, so I'm left with plus 1 times x plus 2. So now what we have to do is we have to simplify by distributing. And then, of course, we know we're going to combine like terms. So I get 3x plus 6 minus 6 over 3x minus 6 plus x plus 2. And I combine like terms, so I just get 3x on top. And then I get 4x minus 2. And, of course, you always got to say to yourself, can I simplify anything? Can I factor anything? And we can. I can take out a GCF of 2. So I got 2x minus 1. And I know you're probably saying to yourself, why do I need to do that? It's because you want to be able to see if you can take something out. Normally, if this was, let's say, a 12, you'd be able to reduce your fraction. But since it's not, that's why this is my answer. Okay? And just one more little point. Alright, hypothetically, if you ever get something and it's like 3x, okay? Let's say you get it down and it looks like this. You do not need to distribute anything. You can just keep it like that, okay? But if you have something like, let's say when you do it, you end up like this on the top. This is when you do have to distribute because it's not simplified enough. You have to multiply by distributing, and then you would have to combine like terms. So that is very important. I hope you see the difference. So this is just together, and this is attached to something. And also, if you take a look at number 7, I know I'm backtracking, you cannot cancel this and this out because, if you notice, this says 3 times x plus 2. This is all together, and it's being subtracted by 6. So, if you see they have stuff in common, you can't just cancel like that. You need to be able to find your GCF, simplify, and combine like terms. Alright, well, thank you for watching. Enjoy. Bye.